Alright, we're going to graph another one of these. I have log base 2 of x plus 3 minus 1. Minus 1 means I'm going down 1. The x plus 3, I set that equal to 0, and I find that I went left 3. So there's my transformations, my asymptote. It went left 3 to the line x minus 3. X equals minus 3, I should say. So let me try to write that more clearly. X equals minus 3. So at negative 3, I have an asymptote. It's a line that I cannot touch. It defines my graph. When I graph exponentials and logarithmics, I better have an asymptote. Alrighty, now I would like some points. I know this is a log. It has not been flipped or reflected. It should have this general shape here, where I'm coming back approaching my asymptote as I come down. So let's see what happens. To punch this into my calculator, I use change of base formula, log of the argument over log of the base, and then my k-shift at the end, minus 1. Let's see here. Let's start over here at negative 3. Step by 1. Auto. Okay. Negative 3, I got an error. That does not surprise me because that's my asymptote. I cannot touch it. I got negative 2, 1, and 1, 0. So negative 2, 1, 1, 0. Negative 1, 0. See if we get 1, 1. See if we get one more good point here. 5, 2. Alright, so negative 2, 1. Negative 1, 0. 1, 1. And 5, 2. 5, 2. 1, 1. I misplanted a point. This should be negative 2, negative 1. I knew it didn't fit the picture that I had set up. I knew it was supposed to go like this, so I have a point that's wrong. I need to fix that. Fix that point right there. So negative 2, negative 1, that makes sense. Negative 1, 0, that makes sense. So now I've got a nice smooth curve. Comes back, falls as it reaches my asymptote, getting closer and closer to it. It continues going as it leaves my graph. See how having a little picture here helps me understand that dot there was out of place and it wasn't going to make my shape the correct curve. Alright, let me erase my points here so that I have room to answer domain and range. My domain is restricted. I have an asymptote in my domain as I look from left to right. So my domain is going to go from my asymptote at negative 3 to positive infinity. Soft parenthesis because I can't touch either. My range is unrestricted. Negative infinity to positive infinity. Just like the domain of an exponential. Alright, x-intercept. Well, I cross the x-axis right here at the negative 1. So negative 1, 0. Y-intercept. 0.585. 0, 6.5. Come on, pen. 5, 8, 5. Increasing or decreasing? Well, it's going uphill as I read it from left to right, so it is an increasing function. The whole thing is increasing, and I'm going to be increasing along my domain. So again, my domain, -3 to infinity. Decreasing, NA, none, never. It's never going to decrease, it's always increasing. In behavior, I have written over here so you guys have a better chance of reading it. I'm going to do the left side first. So as x approaches the left, as far left as I can go is this asymptote. That's it, that's the end of the line. So as x approaches the end of the line, the asymptote, -3. As I approach the asymptote, the curve falls, and it falls towards -infinity. Do the right side now. As x approaches positive infinity, the curve continues to go up ever so slightly towards positive infinity. Again, with the logs, the first part, x is going to approach the asymptote to one side and one of the infinities to the other. F of x is going to follow its range, and it's going to go towards the infinities. Alright, see if we can do another one real quick. Alright, negative times log base 3 of x plus 2. Real quick, I know that this has moved left because of that right there. I set that equal to 0 and I solve. I also have this negative out in front of here, which tells me I have a reflection over the x axis. Okay, so my asymptote would be over here at -2. Just real quick, I like to do a quick sketch. A log function usually comes up like this and goes over. However, this one has been reflected over the x-axis. So now it's going to fall down and go down like this. So I'm expecting it to look like this black function. Okay? Let's get some points so that we can graph it. Put this into the calculator. I'm going to have in my table feature, negative times, I'm going to have to do change of base here, log of my argument, x plus 2, over log of my base. And it was base 3. Hit enter. Starting at the -2, that's fine. That should be undefined at that point. -2, I've got an error. That's undefined. I've got -1, 0. So -1, 0 right here. -1, 0 is also my x-intercept. I've got 0, -6.3. So 0, -6.3, that would be halfway between 0 and -1, just a little bit further down. Y-intercept, 0, comma, -0.63. Okay, let's keep going. 1, -1. 7, -2. Okay, again, it's going to look like this black function here approaching my asymptote. My curve, it better have an asymptote on the graph so that I know what I'm approaching. It defines the function. So all of yours should have asymptotes on them. Okay, so I'll start back here. I'll try to go through and hit as many points as I can. And as I approach my asymptote, I'm rising up towards positive infinity and getting closer and closer and closer to my asymptote. So my domain, I can see, is restricted by this vertical line called an asymptote. So my domain starts at -2, travels onward to infinity. My range is unrestricted, negative to positive infinity. It is a decreasing function, so I do not have increasing. So put NA, none, never. Decreasing, I'm going to decrease along my domain. So again, from -2 to infinity, I am decreasing. In behavior, over here. As x travels left, I go to the left, I go towards my asymptote of -2. And as I travel left towards -2, the curve goes up to positive infinity. As I go to the right towards positive infinity, the curve falls towards negative infinity.